let's get started. So here is the agenda for this session today. We want to do it slightly different from the way we did for previous years. Runtime SDK in general has grown big enough that we didn't want to just go through each of the classes, what they support, and explain in that fashion. So we came up with this agenda where we'll give you an introduction on how to start with the SDK. Then we'll show you some developer or programming patterns to get started with the SDK and then build apps. Then we'll have a functional overview of the SDK where we'll try to cover the different aspects, how we design the API so that it gives you a high-level overview for you guys to choose which areas to work for your apps. And then we'll discuss about the SDK components as well, those classes, but we'll do through some apps, and then we'll see what are the components that are used in those apps, and then talk about the SDK through that. And lastly, we'll just show you or highlight what are the latest or new features that we had in the SDK, probably for the past 2 releases. So that's, in summary, the agenda for today. So let's get started. So building ArcGIS Android apps, what does it mean? So what are the kinds of apps that you are looking to develop? So there can be, like, you could be a developer who wants to just build an app, put it in App Store, and then expect users to use those apps. Or you could be an enterprise user where you already have some kind of an Android app in your enterprise and you just want to bring a map or some geocoding or routing to it. So those are, like, you can build apps for those. Or you want to go with a full-blown enterprise solution for building an app. And apart from this, we also have some example apps or like some inbox apps that ESRI provides, like Collector or Navigator or Explorer, but which can help for your enterprise needs, but you're not clearly happy with, or you want to customize some of these applications and build your own custom apps for that. So these are the kind of the scenarios where you would want to build apps and use the Runtime Android SDK. And for that, like, you need to get started somewhere. So we'll first go through way to get started and how to get the resources to get started. To start with the SDK, you can create a developer account with ArcGIS.com, which is free of cost. You'll get some premium content. You can just go to the developers.arcgis.com and sign up there. You can register apps and have an account. Having an account in ArcGIS, developers.arcgis.com will also let you download the SDK locally. You can sign in and get the SDK locally. Or you can get the Runtime SDK from Gradle, where we host the SDK as an kind of a Maven repository on Bintray. So you sign up, you get the SDK, Runtime Android SDK. You need to have an IDE to develop, so you need to install Android Studio, which is the official IDE for developing Android applications. So which also downloads you the Android SDK for you. So once you have all these, you are ready to build apps. So I mentioned there are 2 types of getting the SDK. One is through adding dependency, getting the SDK from an Maven repository that is hosted, and the other way is to download the SDK locally. So to understand what I mean by getting the SDK through Gradle. So if you start creating an app in Android Studio, you create an empty project. So if you go to the root Gradle file of your Android project, you will have an build.gradle file. That's where you specify what the Maven repository of your dependencies are coming from, and that's the URL that you need to use to get the ArcGIS Runtime Android SDK, which is esri.bintray.com/ArcGIS. And then in your app module, you just go and add your dependency where you specify the compile option and then provide the Android SDK package name and the version with which you want to work. So we host it on Bintray, so we keep all the different versions. So from like whatever we released, like you can, if you want to switch to any version or upgrade, like you just go to your app and upgrade the version number here. And that should automatically, once you build your app, like the dependency should get downloaded from the Bintray. So now we got the SDK, so we want to write an app. So you can write an Android app, but you want to bring a map to your Android app. So how do you do it? So once you create an Android project, you will have a layout, a default layout that you want to see. So you want to add a MapView component to it. So it's like you go to the layout from the resources file, you add the MapView component, and then you come back to your activity code, and on create of your activity, you basically find the MapView that you added in your layout file. That's the view component, and then you have the model component, which is the map, ArcGIS map. You can specify a default base map type, and you can give where you want to, like the level of detail you want to zoom in for the base map, and the location where you want to zoom in first. And once you have your map, you just set your map to the map view. That's it. And you build your app and run the app, like your map view should just be available for display. You also need to make sure like you are giving the permissions, just like any Android app. Like if you are accessing internet, you need to just give permissions to access internet. And if you're using any local data in your app, like you also give permissions to read or write the local storage. So that's how you do in Java. So it's kind of similar in Kotlin as well, but it's much more cleaner, and we do have support for Kotlin. So somebody can just write the same code that was written in Java, like they can just port it to the Kotlin. They can write in Kotlin as well. The model is the same. So you create a map and set the map to the map view. So that should have your first Android app with a map in it. So what else we have with the SDK? There are like different set of resources that come when you download the SDK or you want to work with the SDK. So we have the developer side, which is the developers.arcgis.com/Android, where you get the guide doc. So we explain all the fundamental concepts there in the guide doc, what the functionality that is available. And there is an API reference to work with each of the classes. We have a detailed API reference there. And we have a section for samples that explain how the samples work. And that links you to the code which we host in GitHub. So all our samples are in GitHub. So you can anytime go, download, work with them. You can contribute to them as well. And apart from samples, we are like, I think probably from a year and a half back, like we started rolling out these example apps to the users. So if like these example apps are like not as simple as the samples. Like samples try to cover only as a particular functional area, a class or two. Examples of apps are more like to show the developer patterns or the design models on how to build an app. So we use like different patterns like MVP and things like that. So these example apps are like open source. So somebody can download them and work with them, and you can contribute to as well. And we also have a GeoNet community where you can post your questions, people respond there, and get your questions answered as well. So these are like some of the resources that you get with the SDK. Talking about example apps, so I wanted to highlight few example apps that we have already, and there are a few in progress. So I strongly recommend if you're if you want to understand the SDK, maybe start with the samples. But if you have gone to a level where you understand the samples and then like you want to build slightly an advanced app, and you want to come up with the Android architecture or framework on how to build an app, these apps can be useful as a starting point for that. And since the source code is free, like you can look into it, like how they are modeled, and you can work with them. So some of the apps that we have are like Maps app. There's an ecological marine unit. Then there's a nearby. There's an offline map book. So there's a new example app coming up, which is for mobile data collection. And maybe you can contribute to these example apps as well. Like let us know, like if you have a good an enterprise solution or something which you can put up as an example app. Like you can always let us know, and then we'll try to get that into the example app section. Or like even if you have any ideas, like if you are looking for a particular example app idea that you want us to work, like you can let us know as well. So now that we have seen how to get started with the SDK, I think it's good to understand the programming patterns that are used in the SDK. Shuming is going to talk about some of the developer patterns that we use in developing the SDK.
Thank you, Rama. Before we dive into the detail of our Android API, let's take a look at some developer patterns. These developer patterns will help you to build a responsive native app with great performance. And these developer patterns not only apply to our Android API, they are also applied to all the runtime APIs across the board. First of the pattern is Loadable pattern. This is a pattern that will be able to fetch the metadata of resources such as map, layers, task, and portal item, etc. For these resources to initialize their state, they commonly rely on some remote services or some data set on your disk or some data processing. So to come up with to help you to build responsive native app, we create a Loadable pattern, and to formalize and enhance the behavior of initialize those metadata for those resources. And for those resources that adopt this Loadable pattern, we will refer them as Loadable. And for the remote resources, for all the resources that want to adopt this pattern, they need to implement Loadable interface. This object diagram shows this Loadable interface. From this diagram, we can see that two major properties of the Loadable is the low data and low error. A resource, when it's loading, it can go through 4 possible status, from not loaded, loading, to loaded, or if some error encountered, such as interruption of the network connection or interruption of the services, and it failed to load. When a remote resource failed to load, you can call get low error to get the error message and the cause of the failure. And the Loadable interface also provides a mechanism to allow you to retry loading remote resource which failed to load before. Or you can also cancel loading of a resource if, like say, if you connect to a services which is too slow. And this Loadable interface also supports training of loading. What this means is that some of the loading of the resource depends on the loading of another resource. For example, a portal item. This portal item cannot finish loading before its parent portal object finish loading. So we call this as a load dependency. To simplify the programming pattern, the loadable interface provides a mechanism to transparently cascade loading an object if it depends on another resource. Here's an example of loading a portal. The portal object implements the loadable interface. So you can add a listener, a down listener to this object and load this portal object. Once the portal object finishes loading, the down loading listener will be invoked, and you can call get load status to know the current state of your portal object. If it's finished, it is in the state of loading, or it failed to load. If it failed to load, you can call get load error to get the error message, and then add your business logic accordingly here. The second pattern is ListenableFuture. This is this ListenableFuture inherits the future object. The future object represents a retrievable future result from asynchronous computation. Many of the asynchronous methods in our API adopt this ListenableFuture. It is also an interface. From this object diagram, you can also see you can add listeners to the ListenableFuture. And the ListenableFuture is a promise that a result will return from the asynchronous computation. And there are methods you can check the status of the computation if it has finished or not. And you can also call get to retrieve the result from the computation. And another way to retrieve your result is through a listener. You can get a listener, and the listener will be invoked. And then in the event handling, you can get the result of the computation. And this ListenableFuture simplifies the asynchronous program, but execute the operation in the background threads. And also, we also provide a standard pattern to get the error if the computation failed. Here's a code example for ListenableFuture. This example shows a locator task which implement the loadable interface. So you can load on this locator task at the down listener when you call geocode async. This async method will return a ListenableFuture of geocode result. So in this ListenableFuture of geocode result will promise to return geocode result when the computation is finished. Another pattern is ListenableList. This is interface. This ListenableList extends the regular list, and it binds to data, and it has listener to know when the content of the list change. And many methods, some methods, and also some classes in our API implement this ListenableList, such as the get graphic on the graphics overlay and also the sublayer list and layer list also implement this ListenableFuture. And here's an example of the graphics overlay get graphic. This one return a ListenableFuture of a graphic. So with this ListenableList, you can continue adding graphic to this list, and you can also add listener to this list to know when the content change. Next, I'm pass back to Rama to talk about the functional overview of our SDK. Back to Rama.
So now that we have seen the patterns that we used for API, like how we developed the API so that you understand the patterns that we used, we want to give you an overview of how we organize the SDK so that you get a very high level understanding of the SDK. And whatever I show here, the overview, like it doesn't cover all the classes or all that are part of the SDK, but it's just to give you a very high level overview so that you can choose like which of these components that you can use for your apps. So the core component which we have to work with is the view. So we want some kind of a view in your app. So for us in the SDK, it's the MapView or the scene view, and both of them are extended from an base class GeoView, which in turn in Android is actually an extension of the view group class. And that's the view components that we have. Like along with the MapView, like we have a lot of other view components that are present in our SDK, like that. For example, the graphics overlay, the graphics that you see, or the grid that you see behind the MapView, or the attribution text that you see at the bottom of the app, or a callout, or like if you want to show a location display or a magnifier, or if you're doing any sketch editing. These are all the view components that you can actually see, and they are like very closely associated with the MapView in the SDK if you want to work with any of those components. And so once we see the view components, like the data that is coming to these view components is through this model components, which is the ArcGIS map and ArcGIS scene. Let's see where we get those sources from. So we have this model component like ArcGIS map or ArcGIS scene. The source for that is like you can have a map coming from a web service, a web map, which is a service, or you can get the maps from a mobile map package, which is authored in a desktop environment using Pro, or like you get a web scene from an ArcGIS scene for an ArcGIS scene. Again, it's a web service. So like either you get those maps directly from online or local data like mobile map package, or you create your own set of map from in the client side itself. For that, like you need to create layers and add each of those layers to your map. And like we support like a lot of layers. I just highlighted some of them here. Like for raster data, like you can work with tile layers or the vector tile layers. The services that come from enterprise, like map services, you can use them as map image layers, or if you're working with any raster data, you can use the raster layers, or there's this web tile layer from which you can create your own custom tile layer. If you're working with any third-party tile provider, a service which is providing tiles, you can build your own custom tile layer. Similarly, we support a lot of OGC layers like WMS, WMTS, Bing maps, like they can be OGC or third-party layers, or an OpenStreetMap layer. And for scenes, you can work with ArcGIS scene layer. Again, like each item in this diagram, I try to highlight what the sources are, whether they're coming from an enterprise or an ArcGIS online, or coming from an OGC. And those are all the raster and other types of data. And then we have the vector data, which is coming from like where you can edit things are coming through the feature layer. Again, we have a service feature table, which is basically going to use our feature service that are coming from online or on-premise. And then we have geodatabase feature tables for any local data that you have coming from local geodatabases. And then, like if you're working with shapefiles, like you can still load that as a feature layer from using a shapefile feature table, and similarly a geopackage feature table. So this is where the data is coming from, basically the model components. So you have the view components, you hook your models to the view component, so you will have some kind of an app built. But if you want to do something more, so that's when you need to have some operational components. So we call them tasks. Like we have a lot of tasks within our SDK. Again, for example, a locator task for geocoding, a route task for solving network routes. We have tasks to export tile caches from a web service. Similarly, export a vector tile cache task, or a geodatabase sync task where you can take the feature services offline. Or like you can use an offline map task, which is kind of a combination of export tile, vector tile, or geodatabase sync task, which you would do individually on layers. But we also have an offline map task which can combine all these things and do it for you, take the whole map offline. Again, all the tasks follow the same pattern. You will have asynchronous methods, and if that method returns a job, you keep the job, and like you listen for the status of the job, and once it's done, like you do whatever actions that you want to do. So those are like the driving functionality, like these are the tasks that drive the functionality of the app. And we also have like very other key components, like we have a set of portal API, like if you want to work with ArcGIS Online, like you can work with that. And we have security covered as part of our API, like any enterprise security model that you have, like we support that. And we have some, like we will see in later slides how those things work. And we obviously have symbols and geometry, which definitely we need for any application. So that gives kind of an overview of how we segregated our like we think through our SDK when we build new functionality to it. So with that, so what we are going to do now is we'll see some example apps and show you what are the components from the overview that we saw. Like we'll pick some components from that app and probably go through each of those components through the app. So the first example app is Shuming is going to demo a Maps app.
Thank you, Rama. Let's take a look at one of the example app, Maps app. When you start this map, and a base map is displayed in the map view, and we also turn on the location display, the GPS. And first, I want to log into my organization. Then I can, in my organization, there are a lot of portal items and contents has been authored and shared by my organization. So I want to log in. Here's the URL of my organization. And then here, this is from this browser, this page. We know that we are going to log into my organization through OAuth. And we also support you are able to also log in using your Facebook or Google Plus account. And here, let me use my account in the ArcGIS Online to log in. Oops, sorry. Let me try again. Sorry about that. Let me remove this.
So basically that app is like the kind of the basic pattern that we are trying to show is like logging into a portal with OAuth. So as soon as you try to sign in, like it will redirect to the OAuth page, and then once you pass the credential, it should receive that and log in. It's not letting you log in?
Yeah, I'm logged in right now. So
oh, you're logged in. Okay.
Yeah.
Okay.
Because when I log in, the first thing I'm doing in this app is I get the base map that's configured by my organization and replace the previous base map. And actually, I can see all my web maps that I author or share by my colleague in this organization. There's a list of web maps here. And I can also switch base map because my organization also configure a list of base maps to allow me to use. And I can only access these contents after I sign into my organization. And let's pick one. And besides this, here you can, this is our current location in the convention center. And say if after the conference you want to grab a coffee, you may want to go to Starbucks. When I type in, you see that our Geocoding API provide me a list of some places suggestion. I can pick one. I can pick this one, and it will geocode this address into the MapView. The red symbol represents the location of this address. And I can also, using the routing API, and use the direction services provided by Esri to get navigation or to get direction to this to this destination. And you can see that's and I can compute this direction between these two locations, and that's a list of direction. You can get that from the result using the routing task. So that's all the.
So that's the demo. So you want to go through the features that are present in the app?
Okay. Yeah, we just saw the Maps app. Here's some key features used in this Maps app using Map and MapView, and also Portal API and all security components, and doing geocoding and reverse geocoding, and also routing API. And of course, there's some graphics and graphics overlay after getting the location of the address, add a graphic to the MapView. And next, let's go to these key features briefly. First is the map and the MapView. Based on the MAC model, we separate the content and the presentation using map and MapView. The map defines the geographic contents you want to add to a map view, and it's the map usually composed of base map and some operational layers. The map implement the loadable pattern, so you can load a map asynchronously and add listeners for some events, such as downloading event or load status change event. And also when you switch base map, that's also an event for base map change. So you can add your logic in this event listener to handle some, say, for example, display the loading progress of your map. And we also provide API for you to persist your map as a web map and save to your portal and share with your organization or public. And MapView render a map, and you enable the MapView, as Rama already talked about, that this MapView extends GeoView, which in turn inherit the Android view group. And the MapView control magnifier and also wraparound mode and sketch editor, which allows you to do editing in the MapView and built-in set. And you can also control your extent and scale of display through viewpoint objects. And there's also a couple of listeners allows you to listen to some events. Some of the listeners on the MapView are inheriting from the GeoView, such as the drought status change listener, layer view status change event. And there are also a couple of events are specific to the MapView, like the map scale change and map rotation change. And the next key feature is layer. Layers are the building block of a map. Layers visualize and query and edit geographic data. And you also be able to change a renderer of the layer or the control the visibility and the order in the map. You can switch the order of some layer in the map through the layer object. And layer also implement loadable interface, so you can load a layer asynchronously and you can attach event listener to the object. And besides the loadable interface, layer also implement layer content interface, which you can obtain a sub-layer from a layer. Like some map image layer, they had some sub-layer. You can use this interface to obtain the sub-layer. And also you can fetch legend info from the service and display legend for a layer. And there are a few common properties such as attribution, description, and min-max scale of a layer, and also the spatial reference and opacity on the layer. And like when you build your app, security is one aspect that you can avoid, because most of the time you want to access some private content that's shared in your organization, or you want to access some services not public. So that's you will need to go through the authentication process. And in our API provide a key component, authentication manager, to manage the use of these secure resources. This authentication manager is a central place, allows you to set ChallengeHandler to handle all kinds of challenge. For example, when you access token-based secure resource and you want to access a portal or services secured by PKI, that's the challenge will invoke, and you need to set a handler to handle this challenge. And authentication manager also manage in-memory credential cache. This credential cache will cache your credential before you log in or sign in some portal or access some secure service. And authentication manager also handle to manage a list of OAuth configuration to help you to work with OAuth. and it also manage client server certificates for you. Security is not, it's pretty complicating, so our API provides some default authentication challenge handler to handle most of the common workflow or use case to work with authentication and security. This default challenge handler will provide user interface to handle challenge, and also allows you to set different kinds of credentials, like say HTTP user credential or token-based credential, and also client certificate credential. And it also help you to trust your server when you access a server with self-signed certificate. And to work with this default challenge handler, you only need to add one line of code to your application. Create a default challenge handler by passing in the context of your application. Then set this challenge handler, default challenge handler on the authentication manager. And with that, you'll be able to work with user credential and trust self-signed server, or you can pass in a client certificate to access PKI secure resource. And this is the OAuth is the one which I just showed in the Maps app. That's the authentication approach used in the Maps app, example app. We support OAuth 2. You may not be familiar with the OAuth 2, this term, but you must have been used it a lot when you use your Facebook account, your Twitter account, or your Google Plus account to log in some app. That's the OAuth protocol behind the scene. And in our API provide two approaches to work with OAuth. One is using our default challenge handler. So you only need to create OAuth configuration with client ID and URL, etc. And then you add this OAuth configuration to the authentication manager, and also configure default OAuth receiver in the manifest file of your application. That's all you need to do. And the rest, the OAuth will be taken care of for you by using the default challenge handler. If you want to take care of the OAuth authentication by yourself, that's a class you can use, the OAuth login manager, to use that. And once again, I want to point out that we support login using your social account, such as Facebook or Google+, etc. The next API used in the Maps app is the Portal API. The ArcGIS Online and your Portal on-premise provide rich capabilities. To utilize this capability and access those content, we provide Portal API, and it is a high level. Has high level cost to grain API to access or use and create or share your content. And the key feature, key class for this Portal API include portal, portal user, portal item, and group. And let's take a look at two major workflow that are used in the Maps app. One is the access space map of your portal. Your organization maybe configure a list of base map, and you can use the Portal API to fetch the base map by get the information of your portal and create a query parameter. And you are able to create a list of the query string by the get base map query parameter, and then passing in the parameter to the portal find group async method, then you will get from the ListenableFuture, you are able to fetch the portal item and get a list of base map. Another commonly used workflow is to access your user content, and you can call the fetch content on the portal user, which you get that from your portal. That's the major workflow. And the next API we had is the Geocoding API. That's the, we mentioned the locator task before, and that's a loadable, and you can use ListenableFuture pattern on the geocode async on the locator task, and by passing in the geocode parameter, and you get the result from the a list of geocode results which contain the direction and the label, which is the address, and also the location of the address. And another key feature used in the Maps app is the routing API, and you use the routing API using through the route task. It's also loadable, and the method, async method, also implement the ListenableFuture. So you can see that this is pattern, loadable pattern, and ListenableFuture pattern are applied to most of our API. And you can call the soft async and get raw result, a list of raw results, and with direction and the message. And next, I will pass to Rama to demo another example app.
So this is the next example app, which is still not yet available for you, but it's going to come in April timeframe. So it's a mobile data collector app. Again, the source of it should be available for you if you are looking for an app, something similar to this. So I'll probably do a quick demo of that. Okay. So I'm not going to log into it again because we already saw that pattern. So here is an app for me where I have a data, a layer coming from web service. It has some related records. So this tree server app has a tree layer, and there is an inspection layer, which is its related layer, related table with one-to-many relationships. So this app can work online as well as offline. So I already downloaded it for offline use. So if I want to collect a tree, I just select that, and then I choose the species type. I can see that the address is reverse geocoded and is automatically populated. I select a selection type, give some width there. So I enter some default required fields for data collection, and then I can give some date. And then I created a new tree. So I want to do inspections, which is through its related records. So basically this tree, if I want to add a new inspection record, I can create a new inspection record. I can assess the condition of it, give some details of the tree, say that the tree requires maintenance. And then, I create a related record through the app. So you can see that now it displays and also shows which user has inspected it. So somebody can create multiple related records for the inspection. And then once you do your data collection, you can see that you can also synchronize your offline map. Okay, but yeah, that should have synchronized it. But again, that we want to highlight the features there. Okay, So there seems to be a network issue. So that's why it's not synchronizing. That's okay. But so we are trying to highlight the features in that app. So again, like it's doing the identify. So it was also doing the reverse geocode and the app also uses the portal authentication OAuth for it. It does the connected editing as well as disconnected editing. It also works with related tables, and also it uses the offline map task and to take the map offline and offline map sync task as well. So one of the components that we used is identify. Again, like quickly to see what identify does is identify works on a map view where you can identify a set of layers, or like you want to identify the whole map. Like we have methods for those, and you pass the screen point, give the tolerance, and again, like you see the pattern here. Once the identify is done, you get the results back, and then you do whatever you want with that. And the editing workflow that you saw, it does both connected and disconnected editing. So if you're connected editing, you work with the service feature table, as I mentioned before. And if you're in a disconnected mode, you work with the geodatabase and the geodatabase feature table. And ArcGIS feature table is the base class for this feature tables that are coming from ArcGIS platform. So all the related query methods that you want to perform should be available on the ArcGIS feature table method. So all you need to do is call the method query related features and pass in the feature and some parameters that you want to perform the query, and then you get the results back. And then we also used offline map tasks as well as offline map sync tasks. For the offline map tasks to work, like if you want to export both tiles and vector data, you need to make sure your export tiles is enabled on your service. Similarly, a sync is enabled on your feature layer. So one other thing we also support with offline map task is pre-planned workflows. You must have seen in the plenary demo. There is a separate session that if you want to understand all the workflows for offline data collection, there's a separate runtime session for that. I recommend visiting that. And then, like for synchronizing map, we use the offline map sync task. Again, the map that is generated through the offline map task is a mobile map package. So like it tells like how we are trying to maintain the same schema across different platforms, like whether you author in Pro or like you're trying to download it from a service or you're trying to create yourself in runtime. The schema for the map and the web map or the scene and the web scene, like they remain the same. So we'll quickly do a 3D demo. I'll just switch to Shuming.
Yeah, this is the Viewshed in a 3D. So you can see that you create a base map from also an imagery and add it to the scene view. And then you add a location Viewshed to the scene view. And when you change the when you change the parameter of this Viewshed analysis, it will also change. And you can also zoom in and zoom out, tilt this scene view. It's the same pattern as the map view.
So again, to highlight, like we work with the scene view, and like we have the scene layers coming from the enterprise or the online, and then we can do analysis. We keep all the analysis on an analysis overlay, the results from the analysis. So you can do a Viewshed analysis or a line of sight kind of features that are available in 3D. And we have been doing more work on 3D. So there is a lot more coming up in that in the future releases. Like if you understand the pattern, you probably know like how the scene works, the scene view, and the layers work right now. So it's the same thing. Like in the code, previously we were using ArcGIS maps. Now we would use ArcGIS scenes. So again, for analysis, like you can, like if we have location viewshed, and you create an analysis overlay, and like on a scene view, you can get all the analysis. It's similar to like how you get the graphic overlays on a map. So you can get analysis overlays and add an analysis overlay on top of your scene. So these are some of the new features that recently came in the last 2 releases. We kind of supported OGC layers like WMS and geo packages. As I mentioned, the 3D analysis that we showed is a relatively new component. We have the support for the shapefile, CNC layers, had offline maps, and we also now support mobile map packages with the raster datasets in it or the tile packages in it. One thing we haven't showed, or a demo or something, is that we introduced with the geodatabase is transactional editing. So if you are in your data collection workflows, previously there was no option for you to collect data and roll back the data that you collected, but now we have the support for that as part of the transactional editing. You can visit a demo theater that's happening today afternoon, like to see some of these new features through samples. I would recommend you visiting that if you're interested in that. With that, so we gave an introduction of the SDK. We showed some developer patterns. We gave an overview of the SDK. We went through a couple of 2 to 3 example apps, and then we showed some SDK components through it, and some of the latest features in the SDK. We just highlighted. Like if you want to see the demos of that, probably I would recommend you to coming to the demo theater. So that's all we have for the presentation today, and thank you.
Thank you. Any questions?
And if you have any questions, you can ask us. Yeah.
You said that mobile data collector, you release that demo at some point in the near future?
Yes. Yeah. It's going to be coming up as an example app in this. I think the time frame is April, tentatively. Yeah. And yeah, that uses the model view presenter pattern for app development, and it's really useful. Like you get the full source code controlled to you, so you can extend on top of that. So yeah, we are excited to release that.
I saw that ArcGIS Navigator has offline navigation capability. Are you planning to access this functionality if it has MMPK with network capability?
So yeah, there were a few requests, enhancement requests for us to include the locator and like the locator geodatabase as well as the network geodatabase as part of the mobile map package. We are still reviewing it. Right now, it doesn't.
With the Pro, I cannot see it on MMPK
Right.
with network capabilities.
But
I want to use the navigation
from
this file.
Yeah, right now I think it's not like you cannot work if it is part of the MMPK, but you can work separately as a local network data. You can still use it in runtime, but I think that support is not yet there through the mobile map package. But you can still use those, like any local route data that you have. You can still consume it in runtime.
I can use the local.
Yeah.
Right.
Yeah.
The route task, you can create a route task from services, and you can also create from your local routing database. The same thing to the locator.
It's just that it's not packaged into the mobile map package yet, but we'll probably get there soon. Yeah. Any other questions?
Okay, thank you.
All right, thank you very much.